Hello, 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 and welcome back to Agree to Disagree. Today, we have a really exciting little adventure for you. We have a discussion between Conspiracy Cats and T-Rock on Isochrone Dating and Young Earth Creationists. So, don't worry if you've never heard this before. If you're not prepared for this, we will prepare you. It's fine. Thank you all for coming out. And so before the debate, it was agreed that Conspiracy Cats would be going first, T-Rock would be going second. And so I will give it over to you guys to introduce yourselves and say hello.
Well, I think most people on the show probably know who I am. I will have a chat in a second. So, T-Rock, I'll just tell you how the debate came about, and then I'll let T-Rock introduce himself. I got a notification on the video on Kent Hovind's channel of me and him debating, and I think the chat was talking about Isochrone Dating, and T-Rock suggested that we had a little debate about it. We chatted offline last week. He seems like a really top-notch guy. I'm sure this debate's going to be really nice, but that's how this has kind of come about. T-Rock, tell people what you want them to know about yourself, sir.
Okay, I'm from Central U.S. Don't have any particular credentials that anybody would be interested in. My educational background is mechanical engineering and quality control, NDT, which basically the highlights there are probably dimensional metrology and radiography. Not something I do professionally, though, but it is in my educational profile. But anyway, I am a young Earth creationist. I was basically born this way, so I've been a young Earth creationist all my life. I've been educated entirely in the public sphere, never had, private schooling or homeschooling or anything like that. So it's not like I'm unfamiliar with the process of how evolution and deep time and all that kind of thing are taught. Anyway, I'm representing young Earth creationists here. We believe that the Bible is an accurate eyewitness account of the history of the world at roughly 6,000 years. You might hear some people say 10,000, but the mainstream young Earth creation model is 6,000 years plus or minus a couple hundred years. So yeah, that's basically it.
Cool. And we did say last week, just to clear this up for any young Earth creationists watching, this isn't a debate about atheism or the existence of God or anything like that. My view is that doesn't come into this whatsoever. It's does the science around radiometric dating, specifically Isochrone dating, does it support the young Earth? All right, that's it. So it's not about the existence of God. The Earth could be old if that's the way God wants it to be. Would be my opinion. So it's not about anyone watching. Don't think, this is some kind of atheist versus Christian debate. That's not the thing that's going on there. It's just about the science around the dating. So, Crafty, do you want to introduce the format and we will kick off?
As far as I'm aware, the format will be Conspiracy Cats has 10-11 minutes. T-Rock will also have that length of time. I will be timing it, and then we will go back and forth and have a little discussion back and forth, and then we will open it up to questions in the chat. If anybody does have questions, please do not tag Agree to Disagree. I'm not on that channel at the moment, or on that thing. I'm on my own chat, so it's down in the scrolling little bit to basically tag at Crafty Keela. I will be in the chat. I will be having a look to see at your questions, and then we'll ask them to people, and then they'll get about 5 minutes then to finish up. So that is Brilliant. That is the structure. So when you are ready, Cats, hang on.
You got your timer ready? Is it going to go ding when you're done?
Would you like it to go ding?
I want it to do this. I've got my own little timer, my own little bullshit button, and at the end, I just want. I just like to do that. Can you do that?
No, okay, I will not do that. No, what I'll do is I have it on the stopwatch. So because we're being a little bit more flexible with the time, anything that you get your opponent will get. So
Brilliant.
that's the way I'll be doing it today. So no timer, just a stopwatch to see how long you can actually speak for. But once you get to the 11 minutes, if you go over the 11 minutes, I will be cutting you off. So
cool. I'll try and be as fast as I can. Let's start now then. A lot of terms are going to be mentioned in this debate, and I wanted to do a bit of housekeeping in my opening statement rather than do the normal kind of opening statement. I want to introduce really what isochrone dating is before we get to the reliability of it and radiation in general. So if I can just share my screen, if I just show that. Let's talk about the nucleus. The nucleus consists of, amongst other things, positively charged protons. These protons repel each other, and there's like an electrostatic force of repulsion that wants to push that nucleus apart, right? It's a very long distance force, but nuclei don't just explode, and the reason they don't explode is because also in the nuclei we've got neutrons, and there's another force called the strong nuclear force, which pulls nucleons, it pulls protons and neutrons together, all with each other, and inside a nucleus is like a balancing act between these two forces. Now, to get this balancing out right for a small atom, we need a ratio of 1 proton to 1 neutron just for the small atoms. That will keep the atoms stable, right? For larger atoms, we need about 1 to 1.5. And for those who don't like looking at ratios like that, we can call it 2 to 3. And then that changes again for even larger elements. So how do we know this? How do we know that this ratio is really important? How do we know that that balance is necessary? Well, what we can do is we can look at isotopes. For those who don't remember what an isotope is, essentially every element that we see on the periodic table, there's lots and lots of different versions. We look at this one on the left here. This is carbon. Carbon has 6 protons, and to calculate the number of neutrons, it's a difference between these two numbers here. It's got 6 neutrons, which gives us that ratio of 1 to 1. So carbon 12, as we call it, is a stable isotope. Great. This is another version of carbon. It is carbon because it's got 6 protons. If you've got, you know, the element you are is determined by the number of protons you carry, not the number of neutrons. This has got 8 neutrons. Yeah, the difference between 6 and 14 is obviously 8. That gives a ratio that isn't really favorable. It's not stable. So this will be what we call an unstable isotope. It's likely, or a radioisotope. It's ready to give off its, it's likely at some point to give off radiation. Carbon 14, I'm sure we all know, is radioactive. So how do we know, like I said, that this ratio is really important? Well, what we can do is we can take all the stable elements that we know. So for example, you know, carbon 12 is a stable element, doesn't give off radiation. We can take all the stable ones we know, and we can plot them on a graph of proton number across the bottom and neutron number up the y-axis. And this blue line that I'm moving my mouse over here now is where we will find those elements to sit. We call it the nuclear stability curve. And you'll see it's not random, right? You'll see that when we plot them, they're not peppering the graph and going all over the place. They sit on this curve. This is what tells us that that relationship between the number of protons and number of neutrons is really, 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 really important. Now, let's add to the graph all the isotopes that are not stable. So let's add our radioisotopes. Oh, sorry, just quickly before I do that, it's worth saying that when something gives off radiation, so we've got uranium giving off some alpha radiation here, it becomes a different element. The nucleus changes, all right? We can gain protons depending on what we're giving off. We can lose protons. We become a different element. Now let's put those radioisotopes onto our stability curve. On the stability curve, what we'll see is anything in this green area here that is higher than that stability curve, when they emit their radiation, they emit beta radiation, which is essentially an electron. And that has the process of turning a neutron into a proton. It changes that ratio and it brings any of the elements up here down towards that stability curve. So the nucleus is changing again to get that perfect ratio. If we look at the beta plus or the positron emitters underneath, we get the reverse effect, right? We get a neutron being created from a proton, and that pushes those elements again close to that stability curve. These beta emitters and beta plus and beta minus emitters aren't scattered all over the graph. It's very, very clear that the beta minus emitters are at the top, the beta plus emitters are at the bottom, and they're all trying to go to that stability curve because it is the relationship between protons and neutrons that determines stability. If you're a little bit bigger, maybe over an atomic number of about 82, you're going to be on this right-hand side where the alpha emitters are, and alpha gets rid of 2 protons and 2 neutrons, and on that graph, it throws them quite far back towards that curve. So we know that the number of neutrons and protons, the ratio is really, really important when it comes to determining stability. Now, if I was to take an element and watch it decay, you probably all remember half-life graphs at school. So the red line here is how much of that element is going to be left over a given period of time. But when it decays into a different element, which is the green line here, we can see that different element being created. It kind of mirrors the line, doesn't it? So essentially, as what we call the parent isotope decreases, the daughter isotope of that new element is going to increase. A little bit like this. So I've got my graph here. This green could be like the parent isotope. And as that gives off its radiation, look, we see the daughter isotope increasing. And, you know, it's a fairly intuitive thing to see from here that if we know, and this is going to be the thing in the debate, I think, if we know that at the beginning of the life of the rock, we only had the parent isotope, then it would be quite easy, knowing the half-life, how long something takes to decay, when we look at the ratio between the parent and the daughter isotope to see how old that rock is. But that's only if the sample isn't contaminated. If the sample is contaminated, we're going to get something like this. And what I mean by contaminated is we could, for example, get some of the daughter isotope that's produced by this decay washing in, right? Maybe with groundwater or something like that. And if that happens, when we get a little bit of decay from the parent isotope, we can suddenly get loads of daughter isotope, and that rock looks way older than it actually is. So yeah, we've got to be really careful about contamination. We need to find a way to prove that contamination hasn't happened. And this is where Isochrone dating comes in, okay? This is a bit that, you know, if I bored you to death, this is a bit where you've got to wake up and pay attention at the back of the class. Right. We can look at rubidium. Rubidium will decay into strontium, an isotope of strontium with a mass number of 87. But inside the rock or the mineral that this is occurring in, there'll be another form of strontium, strontium 86. Now, I'll put a blue circle around that because it's going to get a bit complicated. Whenever you see strontium with a blue circle around it, that's going to be the strontium that was in the rock, the stable strontium that was in the rock that's got nothing to do with radioactive decay. It's like a fixed thing, right? Now, as the rubidium decays into strontium, what we're going to see is the strontium 87, the daughter isotope, is going to start to increase in relation to the strontium 86. We're going to get that ratio is going to increase. All right, we're going to build up the 87. The 86 is going to stay the same, and we get that ratio going up. At the same time, the rubidium is decaying, right, and we're getting less rubidium. So that ratio is going to go down compared to that fixed thing, that strontium 86, right? Now, this is important. I'll tell you why it's important. Because we know the percentage of certain elements, of certain isotopes within an element. So, for example, and I've rounded these and simplified it, but essentially we know that chlorine, 25% of all chlorine atoms have a mass number of 35, right? 75% have a mass number of 37. Or have I got those the wrong way around? Bollocks. I think I've got those the wrong way around, but still. Anyway, the point is we know the proportions of specific isotopes within an element. And what that means is if I was to take a rock that had no contamination whatsoever, none at all whatsoever, and I was to plot the ratio of these two isotopes, 87 to 86 on the y-axis, I'm going to get a straight line here. What we get here, these things I've labeled A, B, C, D are different minerals within the rock, right? But inside all of them, they're going to have the same ratio of 87 to 86 because that's just how they exist in nature. Young Earth creationists don't disagree with that. Nobody disagrees with that. Everyone's happy that we know the proportions of each type of atom, each type of isotope. Along the x-axis, what I've done is, or what we plot, is the ratio of the rubidium, the parent isotope, again, to that fixed strontium. So we have two ratios going on here. And you might be thinking at this point, oh, it's getting a bit silly now. We're almost at the end. The important thing is that we know for a brand new rock, this is going to form a straight line. Now, over time, we said that this ratio is going to go up and this ratio is going to go down. All right. So this is going to go up. This is going to go down. As this goes up, right, or as this goes down on the x-axis, is towards the left, isn't it? Towards 0. So that has the effect of pushing all these dots this way. Remember, these represent minerals, and it's these various ratios we've talked about within the mineral. Now, everything I've said so far is without contamination. And without contamination, these minerals all land on a straight line. In a perfect world without contamination. And we can use a gradient of that to determine the age of the rock. If we had contamination that came in different parts of the rock with different minerals that all have different amounts of these isotopes, it would affect that in a way that we wouldn't get anything close to a straight line. It wouldn't be a straight line at all because all the minerals would, these ratios would have been affected differently. So with isochrone dating, we can look to see whether this forms a straight line. If it does, that tells us there's been no contamination whatsoever, and we can trust it when we use radiometric dating. If there isn't a straight line, that tells us, oh, hang on, we can't trust it. So that's why isochrone dating is important, and that's why it gets around a lot of the arguments young Earth creationists present about contamination, things not being trusted. So hopefully that information will come important later on. I'm done.
Brilliant. 10:35. Well done. Well done. Right. So thank you guys for being here. Again, a few people came in late. It is more of a discussion than a debate. But T-Rock, I am going to give the floor to you.
Okay, everybody hear me?
Yep.
Okay, thank you for that intro. Not much to not much to disagree with there. It was a pretty basic intro to isotopes and basic chemistry and isochrone dating. I'm going to actually go through what isochrone dating is a little more technically. And just to be clear, my thesis here from the beginning was what you see on. Hold on, I'm not sharing my screen yet, am I? Okay, hold on just a second. How do I share my screen? Oh, never mind.
All right. So if you hit the share screen button, yeah, and then I think I've got to present it. Just let me know when it's.
It's up.
Maybe I've got to stop sharing. It's not up on my side. Just try it again, mate.
The window's staying up there. Hold on.
Is it stalling a bit on your side?
It does not want to share anymore. I'm hitting the pop-up on the share at the bottom of the screen, and it's not.
Just hit refresh on the browser, and then try it again. You'll pop out for a minute and come back. And if you, there we go. Right, debate over. I win. Let's go. Right. Yeah. Sorry. I did get those isotopes the wrong way around. I did that in a rush. It was 75 for chlorine 35.
Okay, I did it again.
Welcome back. So if you want to try and share, Cats, have you stopped? Yeah. Have you stopped?
I've stopped sharing. Yeah.
Okay.
Yeah. Okay. Yeah, it's coming up now. I can see it.
Great.
Okay. So as I was going to say, my original thesis is what we started out talking about. It's the reliability of isochrone dating. Can we count on it? So it's a pretty generic way of approaching the debate. What it alludes to, it does not allude directly to young Earth creation account. What it alludes to most specifically is that the current accepted age of the Earth is just wrong. So with that, let's see here. Introduction. Isochrone. The word isochrone comes from two words that come together to mean the same age. It's an alternate form of radiometric dating. It requires a radioisotope whose daughter product has a stable and non-radiogenic isotope variant. What that means is the rubidium-86 that Katz mentioned a little while ago has another version of strontium with a different atomic weight, does not come from radioactive decay, and it is stable. And so the common candidates for isochrone dating are rubidium, strontium, samarium, neodymium, and lead. Doesn't require knowing the initial amount of parent and daughter isotopes. plots a ratio of radioactive parent-daughter product on the x-axis. There's more to this. Let's see. The y-intercept is typically greater than 0. The y-intercept represents t equals 0 for the sample, meaning that's when that particular sample was formed. A linear relationship between the ratios of the stable daughter and the daughter isotope and the parent and the daughter isotope demonstrate the isochron by a linear relationship, as you can see in this picture here. Nonlinear relationship, as stated earlier, is basically indicates some type of contamination or other anomaly that obscures the accuracy or the validity. The entire isochron line rotates counterclockwise as theoretical age increases. Commonly uses 6 to 8 crystals per sample, but may use more. Okay, so that's basically the gist of Isochrone dating and how it works. I did want to point this one very important thing about how you read an isochron plot. If you look at these examples, A, B, and C, they're just examples, nothing more. But you can see that those lines are ballpark 45-degree angle on the plot there. But if you actually do the XY slope on these, you'll find out that those angles are nowhere near 45 degrees. As a matter of fact, and I don't remember which ones are which, but 2 of them are less than 1 degree, which means they're very, very shallow. What's happened here is on the y-axis, it's been stretched in order to give a little better visual representation. Now, it's not meant to be misleading in any way. It's just that visually, that's the only way to see it well. If you don't do that, you end up with what actually looks like a very fuzzy or scattered plot on your diagram there. But you need to remember that, and that'll become relevant later as we talk more about this. Okay, where and why it's used. It's used on igneous and metamorphosed rocks that come from sources whose origin is not known from historical accounts, such as the Grand Canyon, marine volcanoes, etc. This is a big red flag. It does not work on any formations of known age from historical accounts. Eliminate some of the assumptions associated with single radioisotope methods, such as potassium-argon, that assumes all argon escaped prior to solidification, or other types that assume there was no daughter isotope present when the rock formed. So this is a plus to Isochrone dating. It does eliminate some assumptions. However, we'll see later that it still comes with its own assumptions. Alleged to provide 2 clocks running simultaneously to demonstrate no migration of parent-daughter or isotope of daughter has occurred. Isochrons are preferred over single isotope methods because they are known because the single isotope versions are known to be unreliable. Isochrons are also used for more ancient dating because C14 methods are considered to not be valid over about 50,000 years. What assumptions are involved in isochrone dating? Now, you might notice that some of this is red and some is blue. There's a specific reason for that. No parent or daughter isotopes have migrated into or out of the sample. It's blue because we will grant that assumption. The rate of decay has always been constant. It's blue because we'll also grant that assumption. 100% of the daughter product was derived through standard radioactive decay processes. This is one I would contest. Started with homogeneous parent stable daughter isotope. Don't need to contest that. Started with homogeneous daughter stable daughter isotope. Don't need to contest that either. Nevertheless, those are assumptions that have to be made. Okay. Now I'm going to start challenging these assumptions. No parent or daughter isotopes have migrated into or out of the sample. Again, not really contesting it for the sake of this, but there is always a possibility groundwater can leach chemicals into or out of the rock. Some radioisotopes are notoriously susceptible to weathering. The rate of decay has always been constant. Again, I'm not really contesting this, but it has been demonstrated that radioisotopes can be accelerated to varying degrees in the lab, even by several orders of magnitude. But for the sake of this discussion, again, I'm not really contesting that directly. 100% of the daughter product was derived through standard radioactive decay processes. This I am contesting. This is a little bit naive. The very process that created primordial, pick your element, uranium, rubidium, potassium, samarium, likely also created its daughter product at the same time. This has huge implications. That means the very first instant that a radioisotope was created in the world, its daughter isotope was also created, and therefore began with a false time signature. No event has happened in the millions or billions of years the sample supposedly existed that would have obscured the dating results. This is also naive. No volcanoes in recorded history have a proper isochron signature. How does a volcano inherit a true isochron profile if none of the young ones started out that way? It's special pleading, basically. Started with homogeneous parent stable daughter isotopes. This is irrelevant. We'll figure that out in a little bit. But started with homogeneous daughter and stable daughter isotopes. This is also irrelevant. Issues with isotopes. There are several issues. I won't have time to sit here and really break these down due to the technical nature, but isotope fractionation refers to the physical separation. It can be induced in the lab and actually is induced automatically by the very process that measures them, the spectrometry. It can also occur naturally, and it can obscure what you get for an isochrone signature. Open systems, of course, is a concern. Origin of primordial parent and daughter elements that I just mentioned previously. Anomalies in isotope ratios in meteor rocks. I'm going to have to skip through some of this. Okay, here's one of the highlights of this whole thing. There is a plethora of foreboding terms associated with isochron plots from the open literature. Pseudo-isochron, apparent isochron, false isochron, mantle isochron, secondary isochron, mixing line or mixing isochron, erupted isochron, inherited isochron, source isochron, and so forth. There's a bunch of them that basically tell you, hey, this doesn't really work. And then probably next, really big highlight, isochron plots can be generated from just about any mixture if it's homogeneous. I've actually done this with a random number generator, and you can plot an isochron line with anything that's mixed homogeneously. And if I still have a second to go, I'll probably, there are some bad examples here. Somebody wants to screenshot that or whatever. But this is my allusion to primordial elements. When a star explodes, this is where most evolutionists, Big Bang theorists believe that all of the elements above hydrogen, helium, and lithium came from. And so the idea here is when this thing explodes, you got these little fragments flying all over the place. How do you collect them back together? Which ones do you collect? What ratios were the parent and daughter elements generated in? You have no way of knowing that. And then you got a similar problem here with how lava flows through a volcano. You get more mixing here that can totally obscure exactly what the dating should be.
1 minute left.
So, alrighty. I guess I'll backtrack just a little bit. Right here, it's actually kind of funny because you can do this. I put this up here specifically, and I brought that up about the graph earlier, about how those graphs have to be squashed to really demonstrate a straight line. You can actually do this at home, mix some stuff together. Doesn't matter whether you know the ratios or not. If you don't know the ratios before you start, you can mix them all together. You can start pulling random clumps out and start counting. The M&M's example here, take 4 different colors. Take, say, 2 pounds of brown M&M's, and then, a few ounces of blue, a few ounces of red, a few ounces of green, whatever. Mix them all up, and then as you pull handfuls out, start counting the M&M's and plot them on a graph, and you can get a nice I did it in Excel with a just random number generation, and I got exactly that. So yeah, that is pretty much it. I will stop.
I'll just take your screen share off. Right. What now, Crafty?
Oh, sorry, I was muted. So thank you very much to both of you for actually sticking to the time as best you could. Obviously, just to let people know, I did pause when we were having the technical issues so that T-Rock could have his proper 11 minutes. So now it's a discussion between the two of you. Katz, do you want to start?
Yeah, I think we agreed just last week just to have a couple of minutes just to comment on each other's thing first, if that's okay. What did we say, T? What was it, 5 minutes?
You're muted.
He's
Yes.
muted.
Yeah, so 5 minutes. Okay.
So you said, sorry, it's a bit creaky. Yeah, that's great. So you said in that, I think, and correct me if I'm wrong, because you did say a lot of things, but the one that I felt came through more clearly for sure was the idea that we don't know at all, or we might not know what the original ratio was. Was that one of your main criticisms?
Well, it's like I said, I wasn't directly contesting that in the Isochrone methodology, but it is a fact that we don't know what the original primordial ratios were.
So for me, that isn't a problem at all for Isochrone dating. So if I share my screen again, which I'll just...
No, exactly, and I agree. So it's not, in and of itself, it's not really a point worth belaboring, because in my presentation, I highlighted that as a blue. I'll grant you that.
Okay. Oh no, that's great. Because there was a lot. I'll tell you what. Then for the 5 minutes, do you want to? Because you did give a lot of points. Do you want to give me one of the points you want me to respond to? Because there was a lot there. What would you rather me focusing on?
Yeah, but probably the two main areas, but I'll single it down. The fact that there are no modern historic examples that can be dated using this method.
Modern historic, so relatively new things. Okay. The thing about radioactive dating is, I mean, the Mount. I know this wasn't Isochrone dating, but the Mount St. Helens rock, for example, that was taken, that was about 11 years old after formation and tested, and it came back as being like 3 million years old, for example. There are margins of error, a couple of percent here or there when you're doing radioactive dating. And if you're going to take something that's just formed last week or the week before, or 10 years ago, that 10 years is going to be well within that margin of error of the testing, isn't it? So with that potassium argon testing with the rock from Mount St. Helens, I think the lab that they sent it to had an error of about 3 million years, and the rock was 11 years old. So really, it doesn't matter what the date comes back. The company will say, well, look, it's come back as being 3 million years old. However, we know that's our error. So actually, we don't know how old the rock is. So, it seems to me like you say, well, why can't we use this method to test something that was formed, I don't know, 50 years ago, 100 years ago? Is that what you mean?
Well, okay, when you say margin of error, I think a lot of people get a really wrong impression of what a margin of error in a calculation like that is. The margin of error is presented as plus or minus X number of years, right? And it gives the distinct impression that the age is accurate plus or minus that many years. But that's not exactly what a margin of error is in that type of scenario. That margin of error refers specifically to the repeatability and the accuracy of your counting of atoms in a mass spectrometer. Because it's converted to an age, it's interpreted as an age, but in and of itself, it is literally just how accurate do I think I counted my beams.
Yes, determined by the sensitivity of the spectrometer.
So to argue that Mount St. Helens has a margin of error plus or minus 300,000 years or 3 million years, it's completely irrelevant. Bottom line is the margin of error is not even related to the age; it's related to how you count.
So, well, I'll finish up with this before pass over to you then with that. If we're talking about radioisotopes that have half-lives of thousands of years, then the change in the number of radioactive nuclei that are still able to decay, the change in the count rate between now and 200 years ago is going to be tiny because the half-life of these things are really long. So it wouldn't be the right tool to choose to measure something that we know has been made recently, because like you said, the mass spectrometer is going to count, if you like, the number of radioactive nuclei that there are still left, the number of those isotopes that are present. And when we're looking for such a tiny difference with the numbers, the equipment's got to be so unbelievably sensitive, to date something 50, 60, 70 years old. So, of course, that's not how it works. And that's why we get these margins of errors. And yes, it is converted into a time, plus or minus however many million years. But that's the honesty of science, just saying, look, this equipment isn't sensitive enough at this point to do some to radioactively date something that's only 100 years old. So the fact that we can't do that, to me, just says, we're using, if you think we should be using Isochrone dating to date something so recent, we're using the wrong tool for the job with that. There are other techniques you'd use to date something that recent.
There are, and I can recommend one. Really good tool to use for dating a formation like that is an eyewitness account.
For something new, absolutely. Well, that's I know I haven't given much of a rebuttal there. I was a little bit not sure where you wanted me to go, but that's fine. I think we've touched on one thing. You have your 5 minutes, and then because I've been drinking lots of water after your 5 minutes, I'm going to have a pee, and we'll come back and do the back and forth. Sorry about that. Someone posted that in the chat before. Is he going to have to go for a wee? I go for a wee every stream.
Yes.
Because I drink. So,
Cat is an old man now. Cat is an old man.
I'm getting there. I'll put myself on mute. Sorry, Crafty.
So I'm going to give T-Rock the chance to do his challenge to your presentation. So when you're ready.
Okay, well, as I stated before, so far Cat hasn't given me a whole lot to disagree with. He has, in his words, absolutely agreed that an eyewitness account is the best confirmation method. That's what science is traditionally supposed to be: observe and repeat. Observation. You can't get away from it. The scientist is an observer. He's an observer of his experiments. He's an observer of his data. He's an observer of his methodology. Bottom line is, you cannot not have an observer. But as soon as you say, oh, I calculate with a computer using some statistical analysis what the age is, and it's well beyond, and the confirmation of that calculation is well beyond observability, you're running into some serious scientific problems and functional problems, because bottom line is that is not how modern science for technology it works. It just does not work that way. If you want to develop a cell phone, if you want to develop a spaceship, if you want to do new materials, for example, for construction of whatever, bottom line is you have to have an observer at the beginning, at the end, and a whole bunch of places in between in order to get a legitimate confirmation that yields functional, usable results, which is exactly not what Isochrone dating is. Isochrone dating is done entirely, if you think about a 4.6 billion at the extreme, 4.6 billion year timeline, 100% of the observation happens down at the very best within the last 150 years or so, which means you had no observer at the beginning, you had none in the middle anywhere except right down at the very tiny end. And you can do the math on a calculator, divide 150, call it 200 years by 4.6 billion years, and that's what percentage of observation you have. Absolutely best case scenario. And it doesn't matter which method you use. You can cross-check it with 10 other methods that you consider viable. They all suffer the exact same thing. They all start at the exact same very, very infinitesimal end of a very long timeline. So anyway, with that, the one of the main thrust of my arguments here is kind of goes back to the M&M example that I gave earlier. I really do encourage people who really think they understand how isochron dating is supposed to be used as a time clock of some sort. Just go mix some stuff up and try it. I will tell you there's a slight scaling issue in doing it with something like M&Ms, because a single M&M is very large compared to a bowl that you might put them in, relative to how an atom or a ratio of isotopes, a single pair, is in a rock sample. Atoms are extremely tiny, whereas M&Ms in a bowl are actually nowhere near that scale. So anyway, bottom line is, go try it. Take some stuff, mix it up, see if you get an isochron line. And again, remember my what I pointed out earlier about the graphs, how they have to be squashed in order to actually get it to look like a line. There's one other technical point that people should be interested in, and that is that when you plot that line, you can also generate what they call an R number, and that R number basically tells you how close the data fit to the line itself. The line is a theoretical plot, of course, and the data points don't usually fall exactly on that line. They're usually off a little ways. Anyway, that R number tells you how good your fit is for the data. A high number would be like 0.999 would be a good fit. A low number like 0.5 would be a very bad fit. Anyway, you have to consider all those and know exactly what you're looking at when you try to do those types of experiments. Later in the discussion, I'm sure I'm about out of time here, but later in the discussion, I'll recommend some additional testing that needs to be done in the real world for isochron confirmation.
Awesome. Just you were just coming up on the 5 minutes, so thank you very much. I like when people stick to the time.
Yeah, we're doing well. Right, on that, I will be, time this. I'm going to go for a wee. I'll be 45 seconds.
I'm not timing that.
Entertain the chat, Crafty, for 45 seconds. Someone start stop clock, go.
Right. Well, just to say, we did have a super chat in for $5 from Sofa King Sleepy saying, I thought this was about a dating website for an isochrone. My ex was full of them. False advertising. So thank you, Sofa King Sleepy. I hope we didn't misconstrue too bad what this stream was about. So yeah, let me see who's actually in the chat. We will be getting back to the back and forth, and then we will be opening it up to your questions. So please, if you do have questions, or if you do have really important comments that you would like for me to put to either one, let me know who it's for. And tag me in them, so I know that this is not just a comment for the chat. It's a comment specifically for the speakers.
Has anyone got a mop and bucket?
Thanks for that. Thanks for that image, Cats. I know. Right. We all know cats can't tech, but cats can't aim. Cats can't aim.
Right. Let's go through it then. Let's get to the back and forth. Look. I hear what you said in the rebuttal, and it would be ideal if we had a time machine and can go back and could observe all sorts of events. That would be great. I just want to present one thing to you. I'm just going to share my screen and then just get your views on this. Let me just do that. I think, as much as it would be nice to have an observer, I think we would both agree that just because somebody wasn't there when these rocks formed to actually watch it, that isn't the same as saying isochron dating doesn't work. The two things are obviously different. Yes, it would be great to have a pair of eyes on it, but that is not the same as saying that it works. The quote I'm showing you now is from a paper from a project called RATE, R-A-T-E, and you're probably familiar with it. It was a collection of 8 young Earth creationist scientists. This comes from their paper, and I do have their paper, which I can bring up and we can look at later on if you want. And in the paper, which looks at radiometric dating and isochron dating in detail, they give us this quote. They say, at today's rates of nuclear decay, that they totally agree, they haven't got a problem whatsoever, that the evidence stacks up for more than 500 million years of decay at today's rate. Okay, so they're happy that using isochrone dating, I'll just hide that for a second, that if we take it at face value, that's the date that they get from it. What are your thoughts on that?
Well, so first of all, the rate project, and just to be clear, I'm not super intimately familiar with the entire scope of the project, but the rate project was the beginning of what I believe was planned to be several projects that would each be conducted independently of each other. Well, I say independently, I mean, you finish the rate project and they had another thing that they were going to do, and then another thing. They had several areas that they were going to cover. But anyway, so in what they're saying in this deal is that if you assume that the entirety of the daughter isotope came from radio decay, yes, there would be a problem. That's basically it. If you assume that 100% of it came from radio decay, radioactive decay, what they're arguing is that 100% decay had to happen inside the 6,000 year timeline, and it would be a problem. But I don't think any of the rate scientists believe that 100% of the radioisotopes or the parent isotope. I don't believe any of those scientists believe that 100% of the daughter isotopes came from radioactive decay. I don't think any of them did.
Okay. Actually, I've read the entire paper, and they do believe that it all come from radioactive decay. I'll show my screen in a minute. What they believe, though, is that there was an accelerated radioactive decay. So what looks to us like hundreds of thousands, if not millions of years, actually happened over just 5,000 years, of which there's quite a lot of problems with that. But they do 100% believe that it all happened due to radioactive decay. So let me just ask you a question. We can get onto accelerated decay if you want to, but let me just ask you a question then. That's strontium-86 we were talking about before, and other minerals as well. You know, for example, we look at argon when we do potassium-argon decay, which is an inert gas. It doesn't drift in and out of crystal lattices or anything like that. You know, it's not very reactive. How are those daughter nuclei being produced and getting into these systems? Like, how is that possibly happening? If it's what's your
so in my slide I show, and actually this kind of goes back to the other thing that you were talking about. 100% of the daughter element comes from radioactive decay. The reason I confidently say that, you're going to have to be a little more specific. Are we talking about specific samples that were tested? Are we talking about the entire globe's worth of radioactive decay? Exactly what are you insinuating that they believe? Do they believe that the 100% of the daughter isotopes in a particular sample came from radioactive decay? Okay, I wouldn't contest that. That wasn't really my point. It has more to do with the global scale because of the alleged heat problem. But anyway, where does other forms of isotope migration come from, I believe was what you were asking?
Yeah, so in this instance, and then I'll go back to the graph, but in this instance, the strontium-86 then.
Okay, so in my slides, I had to kind of breeze through it, but there is a process called fractionation, isotopic fractionation, and it refers specifically to the separation of isotopes of the same element. So in this case, we're talking strontium-86 and 87, right? So there's a fractionation that happens. So whenever you do a mass, you put them in a mass spectrometer and you try and measure those ratios, the very process of measuring them causes fractionation. but it can also occur naturally. Now, here's the problem with natural occurring fractionation. It's not even widely understood. And the reason it's not widely understood is because it hasn't even widely been investigated. It's well known, it's been well known for years and years, decades, that lighter elements undergo fractionation. It was assumed that heavier elements probably don't, at least not to the same degree. However, because of how it gets obscured during the actual measurement, there is a very specific set of things you have to go through in order to discover the natural occurrence of it. So bottom line is, that's the answer to your question, fractionation causes a drift.
So if we go back to the graph then, I know you said before that the starting ratio doesn't matter when the rocks form. Like, we both agreed on that. So based on that, we will both agree that when we measure the starting ratios of these red dots, remember, represent the different minerals within the rock. So we've got a physical rock with lots of minerals all over it. Now, I've obviously only plotted 4 here. This would represent the shape of the line that we get for the formation of the rock, whatever that original ratio was. Now, if you're saying that there is contamination, if some strontium-86 is then coming in or coming out of the rock, what you're suggesting is that the strontium-86 would have to move into the rock, right? It would have to move into each of these separate minerals, which were all completely different chemical compounds. It would have to move in exactly the right amount for each of these different minerals and interact with them chemically, to stay there in exactly the same way, in exactly the same amount for every single mineral in that compound, to prevent this line from being distorted and not being a straight line anymore. How likely is that?
Okay, actually, that's a lot more likely than what you suppose it might be. So two big points. If you could pull your graph back up.
Yeah, sure.
One of the first things I want to point out is this horizontal line is a purely hypothetical construct. And the reason I say that is because you're not going to go, if it weren't, you could go to Mount St. Helens, you could go to Hawaii, they've had some recent eruptions, you could go to Iceland, they've had some recent lava flows and stuff. You could go to any one of those and you could do an isochron sample on them and you should get this horizontal line, but you don't. It just doesn't exist. It's a purely hypothetical construct. And so, but to further the point here, how likely is it that all of that would happen? So in fractionation, it is actually, I'll say mass dependent, although that may not technically be correct, but the mass or the size of the atom in question depends on how fast the rate of fractionation is. So lighter elements fractionate faster than heavier elements, and there's a gradient there. So what you would really see on this curve, I don't know if everybody can see my, probably not see my mouse, but if you had a gentle sloping curve up, going up above that that horizontal line, that would somewhat represent a more legitimate starting point. And then through fractionation, because it's a gradient and it's mass dependent or size dependent of the atom, what happens is you literally get that entire curve, not straight line, you get that curve starts flattening out and appearing like a straight line. So again, it's a purely hypothetical construct, and fractionation actually does flatten the curve and normalize it so that it looks like a line.
Right. So let's just go back to this again. Like when you said you could go to Mount St. Helens, you could go wherever, you could measure the ratios, and you wouldn't get this as a starting point. Okay, so you said that doesn't exist. So what papers, what research are you basing that on? Because I could call up, umpteen different papers that show Isochrone dating actually used where we do get these lines. So what research have you seen that you are basing that assertion on?
Well, I mean, I can say it the other way. You said you can pull up a bunch of papers that show this does exist. Where are they?
Yeah, okay. So like Isochrone dating papers. Let me get some of those in this PowerPoint here. But because to me, just while I'm finding this, it does seem as though what you're saying is like you believe it's just a story and scientists aren't actually using it.
Well, so to be clear, you asked me, you said, okay, where is the paper that shows that this doesn't exist? Yeah. Obviously, no scientist is going to publish a paper that says this horizontal line doesn't exist. That's not what they're doing. What they're doing is going out to real-world examples, pulling the data, plotting it on a graph, writing a paper explaining their findings. That's what they're doing. So by default, you don't get some open literature published paper that says this horizontal line don't exist. It's just, that's not how they work. Instead, you have to go to all of the known examples like Mount St. Helens, like Hawaii, wherever you go in the world. New Zealand's got some recent activity, I believe. Wherever you go, you just have to go pull that data and see what the Isochrone plot looks like. And they all, that's exactly why I pulled up this slide. I can share it again here.
Yeah, please.
And you can comment. You can... you got me back up? Okay.
Yeah, I've got you back up. Let
me see if I can get to this real quick. I have got 9 examples, and this all comes from the open literature of terms that are used to describe the exact phenomenon that I'm describing. They're called pseudo-isochrons, apparent isochrons, false isochrons, mantle isochrons. They've got so many different names for them, and they come from a plethora of sources because this is, I've got what anybody in their right mind would consider a secondary source here, but the secondary source will lead you to primary sources, and you can go and find that these terms are generated from the secular science community because this is what they actually find when they go try to do an isochron sample on anything of known age.
But from that, I can't... Sorry, go on.
I was just going to point out, too, that another big indicator of the unreliability of Isochrone dating is that even after you get something you think you're happy with, 1.3 million years, there's no historic record that contradicts that, blah, 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 and you think, okay, now I've got a good Isochrone date, errors of margin are good, blah, blah, blah. It still has to have a geological context, and Isochrone dating commonly, not always, commonly fails on a geological context as well, which means basically I've got my Isochrone results, but look at this formation over here that is known to be younger than that. Well, okay, now the context of geology shows that the Isochrone plot is wrong. So that's where.
So what examples?
Terms.
What example? Sorry. So you got the list there of these pseudo isochrons. I can't see what studies they relate to or anything like that. It still sounds to me as if you're saying, no, Isochrone dating, it just doesn't work. But what you said at the beginning really intrigued me. You said, of course, scientists are going to say it does when they publish the work. You kind of implied then that the scientists who are going out and using this technique, and I know we're kind of specifically talking about radiometric dating, but it's also verified by other techniques as well, that it's somehow a story that they're making up. I know when I looked at the rate thing, they did try and identify some issues, like scientific issues with the analysis of the Isochrone dating and stuff like that. But it does sound as if you're just kind of saying, no, it's not really a real thing.
What I'm saying is it works when you think it works, and it don't work when you know it don't work. That's essentially what I'm saying. And so here I've got on the screen some examples of where Isochrone attempts were made. And I'm not saying that, the secular scientists are running out there doing an Isochrone deal and just running in storytelling. Although, if you actually read the papers, you can see a lot of the very subjective verbiage in them that suggests that they're not rendering the interpretation based on anything they actually know. They're rendering it on what they think may have happened. There's a big difference there.
Okay.
But so again, you publish a paper for Isochrone dating. In support of it, what you're doing is you're finding an example where you believe it worked, you publish a paper, you give all the data, it looks like all of your ducks are in a row and everybody's happy. But there are plenty of examples where it obviously don't work. And so if in all of the known examples where it does not work because you have an eyewitness account or some other very solid reasoning to say, okay, this Isochrone plot must be inaccurate, if there's so many of those and every single one of them fails on a historic account, why do you think any of the ones that don't have a historic context or a geological context, why do you think they do work?
Well, one of the papers you've got there that you've quoted is Snelling from 2003. Now, Snelling quotes that paper in this document I'm about to show you now, which is the rate document. I'll just hide your screen. Now, Snelling quotes it here in 2005, and he talks about his findings from Isochrone dating. And he talks about what he did and how he collected lots and lots of rocks that he said were from the pre-flood period. So he'd already dated the rocks in his mind before he used them. He'd already said, I've tested these from pre-flood and post-flood times. I think Austin was another one that you've got there. And he found a discordance. He found rocks that he thought were young rocks based on his already preconceived ideas, and ran a lot of analysis and says, well, these aren't adding up. Okay, and that in this rate document, that was a little bit faffy. So I had to go and hunt down that paper to find out what he actually did, because in this document they published, there's no real data, there's no real analysis, there's no anything. It's just him saying, I found a clear pattern of, a clear pattern of Isochrone discordance. So when I found the paper, this is what he found. Okay, I'll just get it up here. This was his discordance that he found. So let me start that. Oh, where's that gone now? Come on, come here. Sorry, just give us 1 second. Get back to my, done a lot of prep for today. Right. Okay. So he found that when he took a rock and he analyzed different minerals within the same rock, right, and used different radioisotopes and run Isochrone dating on the different isotopes in the different minerals within the same rock, he found in a very small sample of those rocks, there was about a 10 to 15% difference in the age yield of the rock for a very small sample. That's what he actually found. And that's what the paper is that you've quoted there. And the conclusion he drew from that was that Isochrone dating doesn't work. All right. So he had a rock, lots of multiple different minerals in it. He used Isochrone dating on them all, and he found that between a couple of the minerals was a 10 to 15% difference. And from that, he's made the statement that you use there that essentially, the Isochrone dating only works when you want it to work and doesn't work when you don't. That was his. Oh crap! I'm not showing my screen, am I?
No.
Bloody hell! Sorry, guys. I thought I was bossing it then, and I wasn't. Right. So let me share my screen. So when I read his paper, this is what he did. Like I said, he took one rock, lots and lots of different minerals within the same rock. He performed Isochrone dating on all those different minerals using different radioisotopes, and he found that with a very, very small number of them, there was a 10 to 15% difference in the age that was judged by the rock. So in other words, there was a discrepancy, which is what I just showed you in that document. He said there was a clear discrepancy. That was it. Now, the conclusion he drew from that is that Isochrone dating just doesn't work. But that's not a clear fault, is it? The rest of the scientific community look at that and say, brilliant, well done. You've taken a rock, you performed some Isochrone dating on this rock with lots of different minerals, and you found a tiny, tiny, tiny discrepancy. And what we then do is we look a step further and we say, well, listen, because you've used different radioisotopes, some of them have got different half-lives, and we've got to remember that when something has gone, things with the shorter half-lives, when we get to less and less and less radioactive particles left, like we talked about before, the sensitivity of the equipment comes into play. So the sensitivity of equipment for potassium argon dating is going to be different for when we're using rubidium strontium. And that's going to be a cause for these tiny, tiny discrepancies in a tiny number of rocks. All right?
Okay.
But ultimately, Sorry, I'll just finish it and then I'll come straight back to you. But ultimately, this bit here, that second conclusion, a 10 to 15% error in a tiny number of minerals doesn't help the young Earth argument at all, because the rocks are still going to be millions of years old with or without that 10%.
Okay, that's a pretty bold claim. So this takes me back to what one of my major points was about the bowl of M&Ms, the cinnamon sugar, whatever, numeric simulation. It has to do with homogeneity. In other words, how well mixed. So if you go back and look at my slide where I give all these terms that are used to describe basically non-isochrons, by way, we're back up here. One in particular that really stands out to me is this one here, mixing line, which is exactly what I'm saying from the beginning. It's a mix. You can get these signatures from a mix. Now, I also included, and so if you were to go out there and do, I'll take the cinnamon sugar example because the grains are much finer, but you really need 4 constituents in a mix to try and run this type of physical simulation. You need one that represents the mass, the bulk of the rock has nothing to do directly with the isochrons or the isotopes that are used in the isochron method, and then you need 3 that do represent them, and those 3 will be in far lower quantity than the bulk will be. Either way, where I'm going with that. So I had this slide in here to demonstrate this thing that happens underneath the crust of the Earth, where you've got all this magma flowing. That is mixing. That's what it's doing. It's in a hot molten state. Viscosity changes, of course, with temperature and that kind of thing. But as this stuff is flowing around, as in its hottest, most least viscous state, that's exactly what it's doing. It's mixing. So whenever Snelling and all those other guys start performing these tests and they see this small variation, are you familiar with the concept of eddy currents?
Yeah.
So anybody who's been around any length of time knows eddy currents are typically, olden days, standing on a riverbank, you might refer to the eddies in a river, right? And it refers to these little sidebar places where the flow is different somehow. Sometimes on a river it's flowing in one direction, but in the eddies it can actually turn around and flow in very small sections in a different direction. And because of that kind of thing, you can get general mixing for the bulk of the flow, but then you can get isolated occurrences of what we'll call anomalies in the mixture. But it's just because of eddy currents. That's all it is. So the fact that you go attempt to do an isochron dating scheme at all, and you get these slight variations, all you're telling me is you found eddy currents in the flow. That's all you're telling me. And so the bottom line is what my initial statement is. Isochrone dating, it literally is just a mixing line, and it's not a valid age assessment at all. 0. There's no relevance to age whatsoever.
So if I show my screen, in fact, just put yours back on. Can you just get the citations that you had on that previous slide? I think it's slide 16. So we look at the names you've got. You've got Austin, Snelling. Who else have you got there? It's just Austin and Snelling, isn't it? Yeah. Okay, that's good. So you've got Austin and Snelling, whose citations you're using. Well, if I show you my screen here.
Real quick on that point, if you look at some of my other slides, I've got some other citations that are in here.
Go on,
and I'll be super quick. Well, some of them aren't going to have the names of the individuals. You'll just have to go to the site. But what I want to point out is there are more references in here, and when you trace them back, you'll also find guys like John Woodmore-Appy, and an interesting name came out in one of those. These are, as I stated earlier, secondary references. So go to them, follow them through to the secular papers, because they do cite secular sources in several of these, especially in their technical papers. Not all of these are technical papers necessarily, but anyway, one of the names that came up in there was, I believe his name was Y.F. Zing. He's a secular scientist that basically published a paper pointing out issues with Isochrone dating.
Okay. All right. So of the two names that you've given us, if we look at this list here, we can see Austin, who was the other one. We can see Snelling down here. These are the people who all contributed and written to this paper. But we can go through it however you want to. None of the people that you've cited so far agree with what you're saying. Their take, they don't mention mixing, they don't mention eddy currents, they don't mention anything like that whatsoever. So given the fact that you're citing their papers, but they actually say, no, isochrone dating does work, but the problem is that there was accelerated decay at a past point in time. How can you cite the papers and say one thing when in their work they're saying something else? Can you see the contradiction there? Like, why are you citing?
Well, I see the contradiction in how you said it, but I don't see in the paper where they actually said isochrone dating works, and the only explanation is accelerated decay. So one of the papers that I went through, in one of my sources cited, was John Woodmore. I didn't see if his name was on that list or not. But there are basically what he's doing when he published his paper was he was saying, look, accelerated decay is not the only plausible explanation. And the rate paper in particular, it's called rate for a reason. Somebody craftily picked the name and gave it turned into an acronym, all that kind of stuff. But the whole purpose of that was to look for accelerated decay. It was not to look for things like what Woodmore did, looking for fractionation and other explanations. So do they absolutely believe that 100% of all radiogenic isotopes came from radioactive decay? No, and I don't think that's what that paper says either.
Okay, I have read it, and if we just show you again, I've read it, and if I just summarize here in the abstract, the major result of the project is that nuclear decay processes appear to have been accelerated during brief periods in the Earth's history. If I was to maybe do a find, Control F, and type in eddy for eddy currents, it's not there. Okay, there's nothing. I've read this start to finish for this debate.
Okay,
these are the people you're quoting. Go back to the beginning.
Go back to that statement. Go back to the statement you just highlighted for us.
Okay.
Now, let's read that again. The major result of the project, of this specific project, is that nuclear decay processes appear to have been accelerated during brief periods in early history. Nothing about that statement says that 100% of all daughter isotopes came from radioactive decay. That is not what that says.
Okay, but I have read the Isochrone dating section of this, which we can read, or I can email it to you. And I can tell you absolutely that nowhere in here whatsoever, absolutely nowhere in this entire section about isochrone dating, does it even suggest for a second that these lines are only produced because of the daughter isotope being washed in or washed out. Let's have a look.
I won't contest that at all. I don't even think it's necessary contamination of mixing and systematic trend of radio.
So here we go.
Accelerated decay was the dominant factor.
So they're not putting the blame, or if you like, they're not trying to make the battlefield about isochrone dating to do with mixing or eddy currents or anything like that. So the fact that you're citing their papers and they have a different opinion to you that they've got here, they believe it's accelerated decay. So again, like what have you taken from their papers that makes you think it's eddy currents or mixing?
Okay, it looks like you're creating an artificial conflict because these guys, the whole focus of this paper is to establish whether accelerated decay has happened or not. And at best, you can say from that statement you just had highlighted is that it was the dominant factor. That tells you intuitively that they don't think it's the only factor. And that particular conclusion from that particular project was also followed up by subsequent research and papers written by some of these same authors and some extra ones that go on to explore other possibilities besides decay. And so if you go through any of my sources that I'm citing, you will find them talk quite a bit about mixing lines and false isochrons. That was the whole point of that one reference that I gave in those basically it's the one on it says contra RBSR dating or something to that effect. Go through that one. That's exactly what the point of that was, is to clarify that there are more than one possible explanations for how you get these so-called pseudo isochrons.
So the purpose of this actually was to find out. You can see here why the young Earth creationist model for the age of the Earth is not consistent with radioactive processes taking place. The main purpose wasn't to see whether accelerated decay was taking place. It was to find out what the reason was. The result of this was they came to the conclusion, the very specific conclusion, that accelerated decay occurred. Now, I'm thoroughly prepared to talk about accelerated decay and why that doesn't work. But again, and I'm not going to bang on about this, but the scientists that you've quoted actually are saying different things to what you're saying.
I just do not think you're interpreting what you're reading right there on the screen very well. I think what you should do is perhaps contact them. They are accessible for the most part. You can contact the guys at, some of them are AIG scientists and some of them are Creation International scientists. But either way, they're typically accessible, and I think all you need to do is just ask them that simple question. Are they literally saying that only accelerated decay explains isochrone anomalies as relates to the young Earth model?
Yeah, they're saying
they're not.
So go on.
They're just not gonna say yes. Only radioactive decay is the explanation, because that's not what this paper is saying.
Yes, because I've read it. I've read it all, and it all focuses on accelerated decay. And I will email it you afterwards. But this is exactly what it says, and I've taken some quotes from it here, because obviously at the beginning that quote I showed you talked about some of the associated problems, and with the associated problems we get things like excessive heat that would have fried and killed everybody, and they talk about the problems that they've got with this excessive heat. One of the solutions is, maybe to solve that problem, God employed some supernatural process which does not occur today or cannot be detected. They can't solve that problem. The problem of accelerated decay with the radiation killing everybody. The quote from that paper is, well, we don't know, but we are confident these issues will be solved eventually.
So that's, that whole thing, that very thing about the heat is really interesting to me, because again, you're talking about a hypothetical problem based on some numeric calculations, and as I've already demonstrated from the M&Ms and the cinnamon sugar example, you can calculate stuff till you're blue in the face, and it does not necessarily represent reality. But no scientist is above those kinds of problems. It happens. But one of the things I would look for in the rate paper is I would like to go through some of their calculations sometimes and see if any of the energy dispersal. Number one, I'd like to know what the volume of parent isotopes are that they're basing their calculation on, and so are they talking about a full global volume that is also obviously estimated? Nobody can actually directly measure how much uranium or how much rubidium is in the earth. There's no way to do that, so you have to estimate them. How wrong are those estimates? Nobody knows. There's no way to know. But the other thing that has always stood out in my mind is the energy that you're talking about converted to heat. Well, there are several energy equations, and they don't all relate to heat. Some of them relate to other forms of energy, such as electromagnetism and more specifically mechanical movement. Take potential energy with gravity, mass times height, that type of thing. So energy can be converted through a variety of ways, and how much mechanical energy absorbed any potential heat problems that may have been there, I don't know. Are any of those calculations in that paper?
You know what? I'd love to have seen some of those calculations myself. The paper is, I'm going to be honest, it's pretty poor. If you want to find a calculation, you're not going to find it in this paper. They give suggestions about what might happen. For example, well, that was a good one. Let's have a look. Oh yeah, here we go. So right at the bottom here, experiments to investigate the direct alteration of decay rates under such extreme conditions were beyond the financial capacity. They haven't done experiments, have not done investigations in this paper. What they've done is just suggested things. For example, this box up here, they've suggested that to accelerate decay, it would be possible, and this was a thought experiment, if you ripped all the electrons off an atom and took it down to its nucleus, then that might increase the likelihood of decay to happen. This is one of the things that they proposed in that paper. So essentially, obviously, we all know if you rip all the electrons off an atom, you destroy all the matter of the Earth. But they are suggesting that as a mechanism for accelerated decay, because that is what their conclusion is. This is the conclusion of that paper. The rate group believes from these arguments at the end of the paper, a large amount of nuclear decay occurred during the genesis of flood and during the other parts of creation, and they've used that to answer everything. So again, I'm not saying that means that what you're saying is wrong, but what I'm saying is that the people that you are citing do not follow what you're saying. They are firmly behind a completely different explanation to the one you're giving.
I don't think it's as completely different as what you're alluding to, but let me look here. A large amount of nuclear decay occurred during the flood. A large pulse of heat was also generated. Okay, so what I want to point out here is that as far as accelerated decay goes, there is really good evidence that accelerated decay has happened, and that was in the form of doing some helium studies on crystals to see how much helium was still trapped in these crystals. Helium being extremely small, it tends to slip right through the lattice structure of crystals very easily, and it is temperature and vibration sensitive. So anyway, bottom line is they did go out. I think it happened. It may be actually in this paper, but anyway, they went out and they found that crystals had an excessive amount of helium in them. Well, okay, so that is one indicator. I just call it an indicator at the moment. It's an indicator of accelerated decay because the half-life of the uranium is so slow that the helium should be escaping faster than it's produced. Well, okay, one indicator. Another indicator is the radio halos, polonium radio halos in granites. What that indicates is because those, if I'm remembering correctly, the particular radio halo in question has a half-life of something like a quarter of a second or under a quarter, maybe an eighth of a second. It's super short. But the bottom line is when you have a radioactive decay happen inside of a solid rock like that, or not solid, it happens inside of a liquid rock. Its half-life is extremely short. The rock is in a liquid state. If it stays in a liquid state for very long, what happens is the granules get annealed, the rock gets annealed, and then the halos disappear completely, which means that those rocks actually had to have cooled extremely fast. So it is also an indicator of accelerated decay, but it's also an indicator of accelerated cooling of some sort.
Well, let's look at both of those then, because you mentioned helium, you mentioned the radio halo. So this again is taken from the rate paper. So everything you've said now, just there, is in that paper that we talked about as evidence of accelerated decay. So just summarize for people watching, an alpha particle, 2 protons, 2 neutrons, is identical to a helium nucleus. And when that's emitted inside a rock, and they specifically use like zircon, the mineral, for this, it can get caught up, it can capture electrons, it can become, a helium atom. What they're saying is that this helium will diffuse out of the rocks over time, and the amount of helium left in a rock can tell you the age, or the amount of helium in a rock can tell you the age of a rock. And if there's loads of helium in a rock, then if the rock's going to be quite old, depending how quickly helium diffuses out the rock. So what the RATE project did is they did an experiment to try and figure out how quickly helium comes out of a rock. So they could say, is it coming out so quickly that the rocks underground need to be really young, or is it coming out really slowly so the rocks underground can be old? And what they did was the most spectacular bit of science I think I've ever heard of. The first thing they did wrong actually was in the calculations for the amount of helium there should be. They only use a uranium decay chain. However, other alpha emitters could have contributed to, but that's the minor thing. What they actually did to measure how fast helium diffuses out of a rock is they took a 34-year-old rock from a really deep borehole, and then they, for no reason whatsoever, they put it in a vacuum. And when you have a rock in a vacuum, the gas is diffused out of that thousands of times faster than they would do at normal pressures, thousands and thousands and thousands of times faster. So for no reason whatsoever, they just stuck it in a vacuum. And then they said the helium is diffusing out of this rock so fast that there shouldn't be, if the Earth was really old, there'll be no helium left in the rocks underground. And I don't know. I'll put a little joke at the bottom of that slide. I've searched and searched. Nobody knows why they would test that in a vacuum. So that was their argument with helium. Going on to the radio halos.
Hold on.
Yeah, go on.
Hold on. Back up. So just on that point real quick. No, I'm not intimately familiar with the details of exactly how they did it, but as I understand it, what they actually did was not just put it in a vacuum and go, oh, the rate's too fast and therefore whatever. There's a lot more to the story than that. What they actually did was sent these samples to a secular lab that had no interest whatsoever in establishing any kind of young Earth model. They sent it to a secular lab, let them do all the work, and they actually experimented across a range of environmental conditions to establish what the rates are given different scenarios. And to put a much finer point on it, I believe it was Russell Humphreys that basically, before they did any of that, before they got any of their results, he basically wrote out a formula and said, in the young Earth model, this is about how much helium should be in there. And he did use the basic assumption that 100% of the daughter isotope from uranium was from radioactive decay for that localized sample. This is not a global calculation. It's for this localized sample. So anyway, he runs his own numbers in advance and says this is approximately how much helium should be in there. And so part of extracting it from a vacuum may have had to do with measuring how much helium came out of it so that they could confirm their calculations. And his calculations that he did before the experiment happened turned out to be incredibly accurate.
Well, just to go back, the calculate, you said he calculated how much should be on there, and you said it yourself, based on the uranium decay chain. But what he didn't calculate was alpha that are being released from things that aren't part, other radioisotopes that aren't part of that decay chain. So he would have underestimated that. But when we talk about the diffusion rate he calculated was calculated
underestimated
from because if you've got alpha particles being given off from atoms that are part of the uranium decay chain, but then you've also got alpha particles being given off from radioisotopes that aren't part of that decay chain, you're going to have more helium. And he only used in his calculation, right? He only based his calculation on alpha particles that would have been emitted from the uranium decay chain. He didn't consider other sources of alpha particles.
Okay, but underestimating the amount of helium is the opposite. It creates an even bigger problem for the long ages. What you're saying is he should have predicted and found more helium than he actually found. But if he found more helium, that just exacerbates the problem. This is the old Earth model.
That was just there to show the flaw in the mythology, not to favour one side or another, just to show there was a flaw in the mythology. But the calculation of how fast it diffuses out of rock was based. You might have said there was a whole range of different conditions, but it was based on when he made his model and said, "Oh, this fits with young Earth." It was based on the diffusion rates out of the rock in a vacuum. Which obviously,
you tell me, why would a secular lab do that in a vacuum?
Well, you just said to me before that they were instructed to try this out in a range of conditions, and of course, in a range of different pressures, temperatures, etc. You're going to get different rates of diffusion. That data was then sent back to Humphreys, but they didn't do the calculation. That data was then sent back to Humphreys, who decided to choose the diffusion rate from a vacuum because that fit his model best.
No, that's what I'm trying to tell you. It's not one diffusion rate that's used in the calculation. It's a broad spectrum of diffusion rates because the temperature and pressure change over time, and you have to have that in consideration. So you can't use one diffusion rate and say, "Poof, I nailed it." And even if he did, it's the very presence and the amount of helium that causes the problem. It's not the rate of diffusion; it's the amount that's still in there. Because
exactly, but the amount that's still in there. So go on. Well, just let me get this dead quick, and then I'll put back. The amount that's still in there is a byproduct of how fast it's diffusing out. If it's diffusing out extremely quick, then there's not going to be a lot in there. If it's diffusing out really slowly, there's going to be a lot in there. So the two aren't unlinked.
So you can show two extremes. You can show what's the fastest possible diffusion rate and what's the slowest possible diffusion rate. And I think what his conclusion is at the slowest possible diffusion rate, the billion-year timeline does not work.
Guys, just to say, I'm going to give this discussion another 5 more minutes, and then I'll bring in questions from the floor. Okay.
Brilliant. I'll get to the radio halos in a second, but honestly, please go back and reread that paper, and you'll see that he's taken the diffusion rates in a vacuum, right, into as evidence that diffusion is happening a lot faster than it is, to try and say that the Earth actually isn't as old as it could be because there'll be no helium left. That's the angle that he's taken with that. Okay, I've read it. I've prepared this because I've read it, because I've gone through it. Right? And I promise you, if you go and have a look, that's what he's done. The radio halos, for those who don't know, essentially, if you've got uranium or polonium inside a mineral and they're emitting alpha particles, that alpha particle can do some damage over time, and it causes these little halos that you can see here, these scorch marks that they look like. Now, the idea is, just like T-Rock said, that the half-life of polonium is very short, and then the granite takes a long time to form. So when the polonium leaves these marks, because granite is still forming, it's not hardened, they get annealed, they get healed, they get disappeared. So they're saying that essentially we shouldn't have these at all in rock unless there was some sort of accelerated nuclear decay that caused them, because the polonium just wouldn't have been around for that long. The starting amount of polonium wouldn't have been enough to cause these after the granite had hardened. But what they don't take into account is, if we do look at the uranium decay chain over here, and I've highlighted it, is polonium. So once all the original polonium has been depleted, it's being constantly refreshed by the uranium decay chain. So we've always got more polonium inside that mineral. So it's not even an issue. It's not even a problem. That would be my.
It's constantly being refreshed by what?
Can you see this on the right here? This is the uranium decay
I
chain.
see.
Yeah?
Okay, so you've got polonium here circled coming from the bismuth.
Well, we start off with uranium, and then we take this route. But essentially, this is all happening inside the rock. And once the original polonium has gone, you can see part of this chain. We just make more polonium from the uranium we've got left.
Okay.
And
okay.
that's what
okay. So what's the half-life of bismuth that the new polonium is coming from?
Well, the half-lives are very short, but we're getting a constant supply. If we look here, for when polonium decays, it decays by giving an alpha particle. So the fact that its half-life is short, right, means that it's very quickly giving off alpha as soon as it's made. It's like I think it's 138 days for polonium, but it doesn't mean that it disappears and doesn't give off radiation. A short half-life means it does give off radiation pretty damn quickly, which is what
sure
is causing those. Yeah.
And so this is kind of the point here, that the cooling happens very fast as well, not just the radioactive decay. The cooling also happens very fast. And so with bismuth creating some of the polonium, that all that tells you is that the cooling of the rock is constrained to probably not much beyond the half-life of the bismuth.
It's not about the cooling, because this occurs after the rock has hardened, and that's why we get those radio halos. Or it occurs all the time.
No, you don't get those types of radio halos from a solid rock. Those are unique to liquid rock.
Okay, so as it's forming, is that right? So what you're saying, that as it's forming and hardening, right, then that's the point where these halos get annealed, isn't it? That's the point where they get kind of like wiped out before it, and when they harden, that's where they're annealed.
They're annealed while it's in its liquid state. They're annealed out of it while it's in its liquid state. And they're captured
the argument is
permanently by the rock hardening, but they are not formed in a solid rock. By that type of halo is not formed in a solid rock.
Perfect. So it's so while it's hardening, but the polonium itself, the argument against these existing in the first place is that the half-life of polonium is so short that these wouldn't that the polonium will be depleted before the rock starts to harden and fix these in position. That's the argument against it, that the polonium will be gone. What I'm saying is that the uranium decay chain from the uranium that's there keeps supplying a fresh load of polonium, so it doesn't matter. It doesn't matter if the original polonium has gone. We're getting polonium all the time, a fresh batch through this decay chain.
Yeah, and it doesn't matter what the source is. It's the polonium half-life is what constrains the fact that it had to have cooled so fast that it captured the radio halo. So while you're going through this temperature gradient and the viscosity gradient, while you're going through that, and you've got bismuth decaying into polonium, can it keep on happening while the cooling process is happening? Yes. But there comes a cutoff point where you got your last polonium halo formed, and then bam, the rock's too hard to form any more of them.
So you're happy the polonium can keep being formed? You're happy the polonium can keep being formed? It's the fact that it can be set in the first place.
Like I said, I'm happy that it's continuing forming up until the point that the viscosity is too heavy for that type of halo to form.
Right. So it's not it's the harden. You're using the speed at which it hardens as your evidence, as opposed to the actual ability of polonium to keep being produced.
The ability to keep producing it is a given, because the short half-life of bismuth. That's not relevant. The point here is that these granites, they capture them from an extremely fast cooling process, which was, by the way, once thought in mainstream science to take tens or hundreds of thousands of years, if not millions of years, to form granites, and they obviously don't. They cool so fast that the granites that we use in construction today obviously cooled within that 38, 45, somewhere in there. Point is, it's days and weeks, not tens of thousands of years.
I'm not sure how that. I mean, you know, you look at a volcano erupting, igneous rock comes out of the volcano. You know, the magma that's still in the insides of the volcano in those vents takes a lot longer to cool than the magma that's on the surface, or the lava now that's on the surface, which you get rock. I'm not sure how that is in any way evidence that the Earth is only 5,000. I don't get the relevance of that. We know that lava can come out and cool quickly.
That's what I told you before. The whole Isochron scheme is not an age indicator at all. It's a mixing indicator.
But this isn't Isochron. This is a completely different thing to Isochrone dating. And
in which case, I'm going to stop you there before we get sidetracked, and I'm going to start asking questions from the chat, because it's easy to get sidetracked into different conversations. So the first one I'm going to ask is from Sable Eagle, who asks, what is a pseudo isochron? What is an apparent isochron, etc.? Can you explain that a little bit and why it's important to your argument? That's for T-Rock.
Okay, a pseudo isochron, they're all just different ways of different names for the same basic problem. The problem is you pull a sample, you do an isochron plot, you get an apparent age, and it's an apparent isochron is another one of those terms that indicates this exact same issue. You get an apparent age, whatever, pick a number, 1.3 million years. But then as soon as you compare it to reality, which you actually know, or maybe in the secular sense, what you think you know, if you compare it to what you actually know, like, for example, when was the last time Mount St. Helens erupted? When you compare it to that, it's obviously wrong because you have an eyewitness account. But if you compare it to a geological context instead, they still use these terms because it doesn't match the geological context. The geological context might say, oh, that's, 4 million years old, but the isochron says 1.3 million, and the error bars don't push you out to 4 million years. So that's where they come up with these terms for. And the fact that there are so many different terms is at least a preliminary indicator to me that a lot of different scientists doing a lot of different experiments have encountered the same problem.
Do you want to comment on that, Kat? You're muted.
No, the terms. No. I'm fine with that.
Okay. So the next question says, creationists have never shown an example of radioactive decay not matching what is predicted. So how do you, what would you say to, or have you any examples where the radioactive decay isn't matching up with what scientists predict to happen?
Are there examples? Yeah, there's a lot of examples. That initial statement was a really bold proclamation, not steeped in actual research. But are there examples? Yes. The Grand Canyon was one of them. There's an example in the Grand Canyon, and those are some of those in my. If you go back and watch this video later, you can glean out the references that I put in there. But one of them points specifically to the Grand Canyon and shows how that the plotted ages are there. So there's a discordant idea, anyway, when you go look at those, what you find is that there's an intrusion through the Grand Canyon, and you literally get different ages from the top of that intrusion to the bottom of it by going at different elevations. You pull samples and do an isochron plot on them, and you find out that, wait a minute, why are the ages kind of flipped upside down from how they should be, or why are they different at all for one particular intrusion that should all have the same age? Anyway, go through the references. Yes, you will find them. There are lots and lots of them.
Great.
My point of view on that one, I'm not familiar with the Grand Canyon argument, so I can't comment on it. But one thing I found wading through this massive document, do Google it, it's worth a read, is that literally every single claim that has been made, when I've gone to investigate it, like the helium claim, like the halo claim, there was other claims that they made that I'll not get into now. Every single one, when actually you go and investigate it, has a really logical, sensible, scientific explanation for it. So I've never ever encountered anything that I've seen in any creationist documents that hasn't been actually quite easy to find the actual scientific answer for.
Okay.
So let me point out real quick as a closing deal on that. One of my references, when you go back, it's that his name is Y.F. Zing, I think. Anyway, he is one of the one of probably many, but one of the secular scientists that has pointed out these issues and said, wait a minute, isochrone dating needs a little closer review. Now, I'm not suggesting he's ditching isochrone dating altogether, but what I'm pointing out is that he has recognized there are issues that do need to be investigated, and you cannot just grab an isochrone plot and say, poof, that's reality.
I mean, personally speaking, yeah, everything that we use has to be reviewed every now and then in order to make sure that we're getting the correct data, or that we're giving out, more importantly, we're giving out the correct data. So it would be worrying if any scientist said that nothing should be reviewed in the way in which we, because if there's a better way of dating things, then surely scientists would gear towards that, I would have thought.
No, well, I mean, I won't altogether disagree with sentiment there. They're obviously, even scientists aren't superhuman. You can get tripped up by very simple things, but you got to think about what the overall implication there is. You got carbon-14 dating. Okay, in carbon-14 dating by itself, you have to have this very mathematically what you would call piecewise function to be able to put together a calibration curve for it in order for it to make sense. So carbon-14 dating just doesn't work by default because you want to run out and count carbon-14 atoms. By the same token, you take a single isotope dating and you find out, oh, wait, uranium is highly soluble. It can be taken in and out of rocks very easily. So single isotope dating has all of its own caveats. And then you go to Isochrone dating and go, oh, wait, we've got fractionation, we've got mixing lines, we've got all these problems. It doesn't work below 200,000 years or whatever the preferred number is. Now all of a sudden you've created so many little caveats for how to date things that you've done two things. You've created so many caveats that you never know which one is really the best one. And you've always got a backup that you can fall back to if you prefer it and say, oh, I think this one probably works better here, which makes the whole thing extremely subjective when it comes to aging. And so one of the points that I really like to make is, if I handed you this pencil, there is not a single dating method available in anywhere in the scientific community that can date this and tell me how old this pencil is without an eyewitness account. And it's not 100 years old.
On the eyewitness account, because we had a few people really ask questions about that. Stable Eagle says, did this guy really complain about the method of dating rock formations that are older than 50,000 years old not being used on rock formations whose formation was witnessed and documented by humans? On the idea of you can't make conclusions based on observations. The question then becomes, from a good few people in the chat, became, well, who observed creation? Who observed creationism?
Who observed? No, that's an excellent question, because as I stated in the beginning, we believe that the Bible is an accurate eyewitness account. So who was it? Well, the Bible says that in the beginning was the Word, and the Word was God, and the Word was with God, and the Word became flesh and dwelt among men. So Jesus is from the beginning.
But do you have the question is there anything from creationism that has lasted other than word of mouth? Is there any proof that it happened in that way other than the Bible? Because the Bible is true because the Bible says it's true is not a great way of determining evidence for.
Okay. No, I'm totally glad to answer. That's a really good question. But it's also a very ill-informed question. The problem here is that when you read the Bible, the one thing that any literate person should be able to deduce is that it is a historic book. above all other things, it's a historic book. God said this, Abraham did that, Noah did this. It's history, right? Okay, so and in saying that, what I'm saying to people who don't believe the Bible, it is written as a historic book, okay? So you're happy to accept a single report of some random volcano off in the middle of nowhere in Africa or wherever, a single report that says that they saw this volcano erupt, and you're happy to accept that historic report and use it in a scientific context. So when you go do an Isochrone date and you plot it and get an age that contradicts this one single random volcano that randomly happened somewhere in the past 1500 years or whatever, you're happy to use that historic report as a scientific backdrop to know whether your Isochrone dating is correct or not. But when you're talking about the Bible, it is a history written that is not just simply word of mouth. It's not word of mouth at all, actually. It is, but what we've got is a written confirmation that was copied, not tens, not 20s, not hundreds, but thousands and thousands of times. It was copied over and over and over. And what this does is it's copied so many times that if somebody incorrectly copies it, there's so many correct copies out there that everybody on the planet can instantly identify the wrong copy. It doesn't match all of the other good copies. So yeah, it's a historical report, and it is intellectually inconsistent to arbitrarily accept a single random report of some anomalous event and reject the Bible's historical report that has been copied and handed down thousands and thousands of years very faithfully, because this is exactly, through a literary comparison, this is exactly how you know that what we have today is accurate, because it matches all of the historic copies to within such a tiny degree of error that typically boils down to single letter mistakes or sometimes occasionally a single word that doesn't really affect the overall meaning of the passage.
To me, the whole argument about observation having to be there, I can kind of sum my opinion up with this. If somebody commits a murder and there's no eyewitness to that murder, and we have to rely on technology to find the proof and convict the person, would a young earth creationist turn around and say, right, okay, you might have killed my brother, my mother, my father, or whatever, but because there was no eyewitness there, I'm not going to trust the technology that's in place that has actually gathered the proof to convict this person, so we're going to have to let them walk free. And I think most times the young earth creationists would say, no, I do trust that technology. But when we're looking at technology of radioactive dating, it's a different story.
Okay, so there's a spectrum of scenarios that can happen with your example of a murder and a witness or not a witness. You can have multiple witnesses. You can have multiple witnesses with maybe one out of a group of witnesses giving conflicting reports. You can have a single eyewitness. You can have no eyewitnesses, right? So the Bible actually has written in its law, in the mouth of 2 or 3 witnesses, every word must be established. So the Bible itself mandates that multiple eyewitnesses have to confirm an event. Well, okay, so what does that mean in a court of law in a scientific context? We're not rejecting science per se at all, but when you go to evaluate that single witness, when you have one witness, how do you evaluate the witness himself, whether he's telling the truth? Well, part of it has to do with his historic reputation, right? You have to basically interview people who know this individual and say whether they believe he's reliable, whether he's coherent, was he influenced by drugs, all that kind of thing. But at some point, you're likely to establish that, okay, this guy is reliable. Now, that's relevant to the biblical eyewitness account, because when you go through the history of the Bible, over and over and over, you establish its reliability by individual instances that can be confirmed historically. So did the nation of Israel exist? Yes. Did the nation of Babylon exist? Yes. Did they have interaction that you can discern through some kind of archaeological forum? Yes. Anyway, point is, you can go through a whole bunch of historic events and establish.
That's a logical fallacy to say that because one thing exists in a book is real, that means that everything is in a book is real. So for me to say
that's not what I said.
That's
not what I said.
That is what you're kind of suggesting, that because the state
what I'm suggesting is there's a whole bunch of things, not a single thing. There's a whole bunch of historic context that you can discover. So there's a pattern. It's not a single one thing happened, therefore the whole thing is true. It's a very long established pattern of archaeological confirmation.
But that's basically like saying, I went to see Spider-Man, and Spider-Man is set in New York, and New York is a real place, so therefore Spider-Man exists. That it's a very dangerous path that you're going down. I'm just saying,
just flipped it back and gave.
I'm not trying to attack you. I'm just saying it's just a little bit of a dangerous path to go down. I do want to get back to the questions. I want to get back to the questions. Because we're not debating. I don't want to debate you. Mr. Andrat asks, why does the guest need to refer to labs as secular? Is he using that term to try and question the results? And is there a difference between creationist labs and what you deem secular labs? So that was just a question on why you were focusing in on secular.
Okay, the reason I highlighted that is because of a very valid point that the creation scientists have made. If they don't use a secular lab, then they instantly become suspect for doctoring their own results. And if they do use a secular lab, that basically says, okay, I'm letting a quote unquote hostile witness do all the work using their own approved techniques. And so what they did was they specifically tried to find a lab that had a very good reputation, had a very well outfit lab, so on and so forth. That way they give the highest degree of certainty that the results are valid.
To me, it doesn't matter what you call them, because at the end of the day, if the work is going to be peer reviewed, it's going to be judged on it's going to be judged on its own quality, isn't it? And I don't think the problem should be secular labs or creationist labs. I think the problem is scientific journals and creationist journals, because the standard of peer review, in my opinion, it just isn't as high with a creation journal.
Cool.
So yeah, that's.
Yeah,
I was just going to suggest.
Go ahead.
But go find a peer-reviewed secular paper that refutes rate, or the results, or any particular experiments that they did in the rate research.
Well, I think when somebody writes a paper, if it's flawed, except then, and especially if it's on a fringe topic like creationism or something like that, then you're not that will go through some sort of peer review process, and it will pass or fail to get into a mainstream scientific journal. And if it fails, it fails. On the back of that, scientists aren't going to say, well, that is a creationist paper. It failed to get in these journals, therefore I'm now going to do a study and disprove it. That's not kind of, people aren't going to jump on the back and try and do debunk papers of it either passes a peer review or it doesn't.
Cool. Traveler X asks, T-Rock, do you know of any scientists that are applying the wrong dating technique deliberately? And why would the results? Why would you consider the results significant if it's actually backing up, or if it's actually, what's the word? Seeing what we expected to see based on the scientists that are doing it correctly.
I apologize. That was a really contorted question.
Yeah, I'm sorry.
Can you summarize the question a little bit?
Sorry. So yeah, what he's asking is, do you know of any scientists that are applying the wrong dating technique deliberately, and would you consider their results significant if it adds up to what is predicted in normal dating?
Well, okay, you have that word deliberately in there, and to be perfectly clear, most mainstream. I know. I'm just saying it was in there, though. However it got there, the word deliberately is in there. And so, just to be clear, most mainstream creationists are not accusing secular scientists of there is no conspiracy theory. There is no accusation of you deliberately are trying to. There are some cases that we can flesh out and say yes, somebody deliberately misrepresented results and whatnot. But by and large, that's not what we're doing. So did somebody deliberately do that? I don't have any examples, nor am I trying to find any. I'm not accusing anybody of that. And as far as the second half of that question, if those results match predictions, well, exactly. It's a little bit vague because how did you make the prediction? Because the bottom line is we're all looking at the exact same evidence, and any given prediction you can make, an opposing prediction can also be made from the exact same evidence. So whose prediction are you confirming? Well, you may be predicting a different prediction on the exact same evidence.
Katz, do you have anything to say about that?
So I was busting for a wee again, and I know that's really rude, but I had to go, so I missed the question. So we'll move on to the next one.
Yeah, the next, there's okay. So I'm trying to get through because there's a few that have asked pretty much the same question, and so I'm just trying to sum up in one question, so I'm not asking the same freaking question over and over. Stating that, can I just clarify how old you believe the Earth is, just for the sake of the question?
For me,
yeah.
The biblical account tells us that it is 6,000 years plus or minus a couple hundred years, and that is the couple hundred years, just in case anybody's curious, it has mostly to do with possible rounding in some of the timelines that are given, because it's a very long segmented chain of numbers and events that go together. So rounding errors can account for some of the uncertainty.
Right. So the questions that are surrounding the 6,000-year-old claim, the approximately 6,000-year-old claim, the questions are kind of, for you, what would debunk that claim for you? Trying to phrase this, if something showed that something was like 8, 10, 20,000 years old, what would prove that in your mind? And what is the margin of error that you're willing to go to for the 6,000 years?
Okay, the 6,000 years in my mind, my margin, my personal margin of error is probably at the outer limits of about 300 years plus or minus. Now, what would convince me otherwise is essentially how I'm hearing the question. What would convince me that something else was true beside that? Well, this is obviously a highly hypothetical, philosophical type of question. Let me ask you this in kind of response. Take the most trusted person you know in your life, and they said such and such an event happened. How willing are you to say, no, you're wrong, that did not happen?
Go on, Katz.
No, I was just putting my hand up when he said, take the most twisted person you know. So I was just saying that could be me.
Just really quick before I let Katz come back in on that, hello to Creaky Blinder, who is sitting in the chat. It's good to see you.
Hey, bud.
So, Katz, what have you to say about that question?
Well, it comes down to evidence, doesn't it? I think all the evidence is that everything into. Well, I'll tell you what. I'll show you exactly what I think about this. When I was playing through that document earlier on, the people writing the document, or the people that were cited by T-Rock today and the others, they all agreed that modern science suggested that the Earth was millions and millions of years old. They all agreed that, and it wasn't. But then they had to say, well, mainstream science says this, so let's create an ad hoc reason that might not be true, that causes other problems. So, for example, the accelerated decay caused huge amounts of heat, which was a big problem. which caused another problem. Why didn't that kill Noah and all the other animals? And then it all comes down to what I've highlighted. This is actually in that document from those scientists, right? That, look, we don't know what protects everyone from the God has supernaturally protected them by some unknown mechanism. So it's not about presenting evidence. The belief is, whatever evidence is presented, the belief is that God is bigger and better and will override that evidence, and whatever conflict there is there, like cognitive dissonance or whatever the conflict is, it doesn't matter, because we don't need to understand how God has got it sorted. He's just got it sorted. So I don't think that a young earth creationist is going to be convinced otherwise, which is fine.
That kind of brings up an interesting point about the flood and about the whole God of the gaps argument thing. Of course, the evolutionists and the Big Bangers and the long agers have their own time of the gaps thing, chance of the gaps. But anyway, the whole God of the gaps argument basically says, okay, every time I don't understand something, I'll just let God be the explanation for it. Well, okay, from a purely scientific approach in a creationist world, and speaking from my own perspective and from what I've seen other, the actual scientists, PhD scientists in the creation sphere do. But I'm not going to invoke God unless there is an account in the Bible that says God did this. And so if I don't understand, radioactive decay, I'm not going to say, well, God must have done that, because there is nothing in the Bible that explains radioactive decay and God's role in that. What I do read in the Bible, though, is that it says, God speaking, he says, even I do bring a flood upon the earth. And so God is basically taking personal credit for causing the flood. And so if he took personal credit for causing the flood, then it's reasonable to assume that he had a plan. He said he had a plan. He instructed Noah to build an ark. He instructed all the animals to come to the ark. He gave all these details about how to proceed with it. And so this is not a God of the gaps argument. It's a historic eyewitness account of the event. Now, how does that relate to the heat argument? Well, you're back at a hypothetical problem. It's purely hypothetical. You have to know what the volume of and which parent radioactive isotopes are involved here. You have to know the volume, you have to know the amount of acceleration, and you have to know where the energy goes. You have to be able to parse it out correctly. How much of the energy went to heat, how much went to mechanical movement. You can go out there in the middle of the ocean right now and you can literally see cliffs miles high in the ocean floor from where something shifted drastically. And so that's a lot of mechanical movement there.
Yeah. No, get you. But I would say, just before we get to the next question, I would say that you are right. You have not once in this debate said, well, God can do that. You're right with that, 100%. But what I will say is that because of your faith in young earth creationism, because of that belief that you hold, I would say that you instantly, when somebody will mention a new radiometric dating technique to you, your instant go-to mindset will be, well, that's not going to work. And then you look and try and find reasons why it's not going to work. That's what that'll be your go-to.
Yeah, and so this is exactly why I brought up the example of ask the most trusted person in your life about some event that they witnessed that you didn't. How willing are you to contradict that most trusted person in your life?
Oh, I thought you said twisted. That's why I put my hand up.
Okay. Well, I mean, for me, I can only speak. Oh, he'll be back, I'm sure. For me, just on that, it comes back to reliable narration. And if you can trust in the person, T-Rock, I'm just saying, just for me, that question of, do you trust the your closest person, and would you challenge them on what they've witnessed that you haven't? For me, I can just say it all comes back to reliable narration. So if they have told me on a consistent basis, things that have turned out to be true and that can be proven to be true, then yeah, usually I would take their word for it.
Well, thank you, because that's exactly the point I was making earlier. When you go through the Bible and look at identifiable historic events that you can confirm through archaeology, there's a big long line of those confirmable events. And if you read any particular book in the Bible, what you can quickly gather is that there is a series of writing styles that are distributed throughout the Bible, indicating that not one person did not write the entire thing, but there are multiple. There are multiple authors, and so they are actual eyewitness accounts. And so the young Earth creation position is basically summarized like this: we have a trustworthy eyewitness account. Evolution does not. Evolution, nobody can observe the Big Bang. Nobody can observe star formation. Nobody can observe planetary accretion. Nobody can observe abiogenesis or evolution through deep time or any of that. It's all storytelling. There is no witness. By design, evolution kicks out all of the eyewitnesses and says only the eyewitnesses today that are staring at the pile of bones in the dirt like a witch doctor trying to discern what they mean. That's all evolution allows.
I think we mentioned that before. You know, we opened that with on the debate with that just because someone's not been an eyewitness to something doesn't mean that it's not real. Doesn't mean that it's not happened. It doesn't mean that we can't use technology to identify that. So I don't like it as an argument
with that. We don't disagree with that in principle.
Personally speaking, I find it very hard to trust eyewitnesses that cannot be verified. We don't know their names. We don't know what their background was or how they actually wrote it. So reliable narration for me is important. But I will go on to the last question because we have been here for a while, and I'm going to then give you guys 5 minutes each to sum up. I will ask for T-Rock to give his sum up, and then I will ask Katz to end. So the last question, just to kind of break with the tension a little bit. Did dinosaurs and man walk the earth together?
No.
Katz, no. Absolutely not. Absolutely yes, they did. It's indisputable to me. It is completely indisputable. Yes, they did walk together. Number one, eyewitness account that they were created on the same day. Number two, even the biblical account gives an example of Behemoth and Leviathan. Leviathan technically isn't a dinosaur because it's a marine creature, but nonetheless kind of falls in that same time span as far as secular dating of the existence of dinosaurs and stuff are concerned. But beyond that, there are inscriptions, drawings, carvings all over the world that anatomically correctly describe dinosaurs, and there are stories, written accounts throughout history that very straightforward, not in folklore sense, but very straightforward accounts of people encountering what they call dragons in ancient times. Ancient being, 1,000 years ago, 1,500 years ago, maybe beyond that, whatever. But the point is, it's in recent man history.
All right. Well, I am going to give T-Rock 5 minutes to sum up the entire debate for him. And, well, not that it was a debate, it was more of a discussion, very, very interesting discussion, but just to sum up things for you. And then I will give Katz 5 minutes as well. So when you're ready.
I'm setting the timer for this. Okay. Recapping, the whole thing started out as a discussion about isochrons, and we went off on various other paths. So I'm going to recap isochrons mainly here, which I don't think I was refuted at all. Isochrone dating is easily confused, at best, easily confused with mixing lines. Homogeneous materials do result in an isochron-looking plot. If you take the time to go through those steps, you can get an isochron plot. You do have to know how to do it. So you can't just randomly throw some numbers on a page and say, oh, that doesn't look like an isochron to me. Well, you have to know how to do it. But nonetheless, homogeneity alone can create an isochron plot. So they are absolutely not an indicator of age of any kind and can't be used for that. And so to recap some of the reasons why, again, it has to do with the fact that primordial isotopes are created through a process that instantly gives you a false age indicator, because the daughter isotopes are created at the same time that the parent isotopes are, in whatever ratio. It does not matter. Whatever ratio they appeared at primordially, you instantly get an incorrect age by looking at them. Secondary to that is, after the supposed accretion of the planet Earth, you end up with a bunch of hot molten lava that actually generates the modern sources for isochrone dating, and in its liquid state, all it does is further homogenize with some minor eddy current stirring that creates a little bit of an anomaly in terms of exactly what the ratios that you might find, isotopes in. But the bottom line is, in a very practical sense, homogeneity alone is easily confused with an isochrone plot that's supposed to be interpreted as actual time when it's not. It's literally just a physical mixing. So that's kind of some of it. Again, I encourage people to actually try some of those numeric. Probably the easiest to me is the numeric simulation, although anybody who's computer challenged may not really know how to do that. But the idea is that you randomly generate a very large grid of numbers, and you want 4 constituents in any experiment that you do. One represents the mass of a rock sample that's it's not the parent, not the daughter, and not the stable isotope variant of the daughter. It's neither of those. It's literally just represents the bulk of the sample itself. Those isotopes represent a very tiny fraction of the overall mixture. But nonetheless, when you do that, you generate a numeric plot where you leave a whole lot of what I'll call neutral agent in there. And then you can mix and match the ratios however you want. It does not matter. You will find out, something I didn't mention earlier was that you will find out when you do isochrone plots in real life, and probably in numeric simulations, it may be possible to do this as well, but you can actually end up with a future isochrone age, which is also very telling. How do you get a future isochrone age? Well, I don't have enough time here to really parse it out, but basically the slope of the line is backwards compared to a correct forward sloping line with a positive slope. It'll have a negative slope on the same graph, and those do happen in practice. Beyond that, my overall statement is that isochrone dating is not a reliable way of dating. It's not actually doesn't equate to a timeline at all. And the best indicator of the age of anything, Isochrone or something on your desk, working camera, a pencil, doesn't matter what it is, the best indicator of the age of that thing is an eyewitness account. Always has been. Arbitrarily rejecting eyewitness accounts with no really solid reason is basically a self-defeating argument, because you're playing the role of the eyewitness who's rejecting somebody else for being an eyewitness. So I guess I should arbitrarily reject your account as well. And so the Bible provides a eyewitness account that starts at the very beginning by somebody who mandates that the truth must be told, whereas evolution mandates that there can be no eyewitnesses except people in the present day and arguably even in the future, because science is supposedly self-correcting. What we understand today may go away, and so it's obviously another form of self-refuting viewpoint.
Cool. Thank you very much, T-Rock. So before Katz actually does say anything else, I really do want to thank both Katz and T-Rock for, one, sticking to the time, and two, to being so respectful towards each other. And thank you guys in the chat for coming out. So Katz, if you want to sum up the discussion.
Yeah. It won't take long, but this is my closing argument. We're sat here now, thanks to modern technology. We're all talking to people across the Atlantic Ocean. There'll be people in Australia watching. There'll be people from all over the world. After we're done, I'm going to go down and open the fridge, which was got some beer in. I'm going to have a cold beer thanks to our understanding of thermodynamics. I'm going to watch Lucifer. I'm really enjoying that on my big TV and get the LED lights on. And this technology is amazing, Unfortunately, we all have some health problems from time to time. We'll go into hospital and we'll trust what the doctors say, and we'll have our MRI scans, which are based on technology. We'll get in our cars to go to the hospital and then the pub afterwards, but leave it at the pub, don't drink and drive. And I love the technology they use to freeze the beer or make the beer really cold, when it comes out the tap. You get all the frost on the tap. It's brilliant. Modern technology is absolutely fantastic. And I'm just amazed to find out that modern technology that works in all these areas is brilliant. However, if we take any modern technology that's linked with radiometric dating, it's shit and it doesn't work whatsoever. It's just pointless. It just doesn't work. So either we've got technology cracked and we know how to make it and it works. It's absolutely fantastic. But anything to do with radiometric dating just doesn't work. Or the fact that the radiometric dating actually is used over and over again to get the same results and is supported by other things like dendrochronology, thermoluminescent dating. I could go on and on and on. The history books, history records as well support it, etc., etc. Maybe actually the technology is right, and maybe the issue is for young Earth creationists, from my opinion, and this will be where I leave it. This has never been a discussion about does God exist or not. When me and T-Rock spoke last week offline to arrange this debate, I made that very, very clear. My stance is clear, that somebody who's a young Earth creationist has read the Bible and they have their faith in God, which is fine, right? But they've misinterpreted the Bible quotes to make them think that the young is old, just like some people misinterpret the Bible to say that the earth is flat. And I know T-Rock isn't one of those people. And I think that's what's happened. And ultimately, that's not something that I'm going to change somebody's mind on, but it's nice to have the discussions, isn't it?
It was fantastic. Thank you both. And thanks to everyone in the chat for submitting questions and just being here, listening to the debate. Hopefully we will be getting back to a regular schedule, at least once a month. And on our community tab, if you want to learn how to debate and take part in some of these debates, we do have the Discord open, and we will have little workshops and stuff. So you can learn how to debate and then become part of the channel that way. So other than that, is there anything else anyone wants to say?
Yeah, I want to say real quick, I want to thank you, Crafty Keela and Conspiracy Cats, for hosting this. And I really do appreciate the civil discourse. Not all of the quote-unquote debates, and as Crafty has pointed out, this is more of a discussion, but not all of those things out there are very civil. Some of them are very painful to listen to because of how much, mudslinging and shouting over each other and that sort of thing. So very much thank you for a nice civil discourse. The only other thing I would say is that radiometric dating technology is not equivalent to modern functional science. It's not. It's measuring things in that sense. Yes, in interpreting what happened millions of years ago, there is no process that takes millions of years that can be used in any modern technology. It's completely pointless. There are no amount of people going to live long enough to see that.
The debate is over.
Sorry.
It's so easy. It's so easy to get back into it. But yeah, the debate is over. You did very well, and I thank you.
Big thank you. Yeah. Big thank you to you guys.
Thank you very much. I will end the stream now.
Take us out.